Matter is familiar to us, even if all the microscopic particles that compose matter are not familiar to everyone. We're all aware of protons, neutrons, and electrons that make up normal atoms. In astronomy, we're also aware of neutrinos, which equal in abundance the protons and electrons. Physicists have learned that protons and neutrons are not fundamental particles, but are composed of fractionally charged quarks. It turns out that each of the particles just mentioned has a mirror image twin in antimatter. Antimatter is a set of particles that have opposite quantum properties to matter particles. For example, the antiparticle of the electron is the positron. The antiparticle of the proton is the antiproton. The antiparticle of a charged particle has the opposite sign of charge, but there can be antiparticles for neutral particles as well. Each particle has an antiparticle twin, and yet in the natural world we hardly ever see antimatter. Antimatter was predicted in the 1930s from the theory of quantum mechanics, but has rarely been seen. It can be created microscopically and fleetingly in the laboratory, but in the universe as a whole, matter seems to dominate. Astronomers have put sensitive limits on the possibilities of antimatter, so we know that there are no antistars or antigalaxies or anticlusters. The universe seems to be overwhelmingly made of only one of two equal species of matter, and we need to understand why in terms of cosmology.